Good morning, good afternoon, and good evening to all our attendees. Welcome to this Hager's webinar on Elcomnet Electrical Design software, which is mainly used for short circuit calculations. For those who are new to Hager, we are a specialist in electrical installations, focusing mainly on energy distribution, lighting control solutions, home automation, and cable management. We are a German company founded in 1955, and today we sell our products and solutions in over 120 countries. We do a turnover of 2.2 billion euros. We have 24 production sites, 19 of them are based in Europe. So we've been here in the Middle East region for over 20 years, and the idea of today's webinar is to discuss the functions, the features, and basically how you can use our software to verify your electrical calculations in a fast and easy way. So before I begin the presentation, I would like to lay out a few rules that we have for the webinar. During the webinar, your microphones and cameras are switched off, so we will not be able to hear you or see you. But if you do have any questions, you can put them in the chat box, and we have a moderator who will be uh, responding to all your queries or questions or clarifications that you have. We recommend you use a headset so you have better clarity in this webinar. We have a poll which will be asked at the end of the webinar, and of course, we have some giveaways which will be given. After the webinar, you will all receive email which will have the recording of the webinar. So this webinar is recorded. It will also be posted on our YouTube page. And of course, we invite each and every one of you to register for our future upcoming webinars. Let me introduce myself. My name is Asad Shariff. I've been working with Hager for around 8 years now, and I've been working in the LV switchgear industry for over 14 years. I'm currently the prescription and export area sales manager for Hager Middle East, and I will be conducting your webinar today. All right. So let me also share with you the agenda for today's webinar. So I will be beginning with an overview of the software. I will be showing you the basic functions of the software, some features, benefits, and also the steps on how you build your electrical diagram and your network. After this, I will be doing a live demonstration of the software, so you will see it live on the webinar, how the software operates and how it works. Of course, after that, at the end, we will have a Q&A session. So we will try to answer as many as questions possible at the end of the webinar session. So please feel free and write in any of your comments or questions you have at the chat box at any time during the presentation, and we will ensure to answer them at the end of the presentation. Okay, so let's begin the overview. But before I talk about the software, something which I want to discuss in the beginning is, of course, the types of faults, the different types of overcurrents which you will find. Mainly, you have the overload and the short circuit. I will pick on the short circuit for this presentation because our software can do the short circuit calculations. And I want to first start off by asking, what is a short circuit? We all talk about it, we all see, calculate it, but what is a short circuit? In simple terms, it's electricity taking the easiest path. Everybody knows the current flows in a closed loop, but when an electric current flows down the wrong or an unintended path with little or no electrical resistance or impedance, it causes a short circuit. Because the alternative route in the circuit is generally more conductive, a lot of current can flow through it. And within milliseconds, the current can become thousands of times larger than normal. As a result, we can have equipment damage, electrical shock, or even a fire. But what causes and how does a short circuit originate? So basically, there are a few key reasons. One is faulty insulation. This is one of the major reasons why you can have a short circuit in your network. The insulation of your cables of your installation becomes bad, and this causes short circuits. Loose connections. This is another very common reason. When your terminations are not good, when the torque settings are not as per the recommended settings by the manufacturer, you tend to have loose connections. Also, during after a certain period of time, you might have some vibrations, you might have some loose connections due to this, as a result of which you can have short circuits in your network. Last, household pests, rats, mice. These can also cause short circuits in your networks and panels. How do we protect ourselves from short circuits? I think the basic one is circuit breakers. Circuit breakers must be provided to limit and break the short circuits before they are thermal. Thermal effects like conductors melting, electric arcs, fires, and mechanical effects like electrodynamic forces become harmful and dangerous to human life. So, circuit breakers are the most important protection that we can have against short circuits. Let's talk a little bit about the intensity of short circuits. So as you can see in my slide over here, basically we have three types of short circuits. You can have an ICC3, which is basically a three-phase short circuit. So you see you have your neutral, R phase, Y phase, B phase. If you have a short circuit between all your three phases, that is the maximum short circuit which you can have in your network. You can have a two-phase short circuit between your two phases, any two phases. It's called ICC2. Or you can have a short circuit between a phase and a neutral. This could be the lowest short circuit intensity which you can have. So you see, we can have different levels of short circuit in your network. So whatever calculation you do has to be based on the maximum short circuit level that you have in a network. This is very important. So the circuit breaker selection which you make has to be based on the maximum short circuit selection. We also have IZ, which is the maximum intensity of the current admissible in the conductors. So this is also very important parameters because your cables, your conductors can carry a certain current. And when it goes beyond the certain level, that's when the problems start occurring. So always your ICC is much, much, much greater than the IZ in your network. On what does your short circuit depend? So how do we calculate the level of short circuit? So there are a few important parameters. The first and foremost is of course the power, the type and power of your transformer. So this is one of the big parameters which determines the short circuit that you might have in your network. Something also important is the length of the line. So the distance, basically, the distance from your transformer to your panels, from main distribution boards to sub-main distribution boards, from sub-main distribution boards to final distribution boards. So the length, the distances, the type of conductor, whether it is a copper or aluminum, can also have an impact on your short circuit levels. And lastly, the cross section. This also plays a major role in the short circuit levels that you have on your network. So the power of the transformer, the length, the type of the conductor, whether it's copper or aluminum, and finally the cross section of the conductors. How do we calculate short circuits? So we have three basic ways. One is using the formulas that we have, which is quite complex. It's long, it's tedious, takes a lot of effort. We have tables from manufacturers, which makes things easier, but I believe the easiest and the simplest and fastest way would be to use softwares. And Elcomnet is one such software which makes short circuit calculations very, very easy. So let me explain to you the concept of our software that we have. So the software is designed to calculate low voltage electrical installations in accordance with IEC 60364 standards. So whatever calculations we do on our software is based on IEC standards. So the IEC 60364, for those who are not aware, provides additional requirements, measurements, recommendations for the design and verification for all types of low voltage electrical installation. So this is very important. So we always follow the IEC standards. The software produces electrical diagrams, reports required for design and verification of any network. So you will see as I move on in my presentation that the various types of reports that we can do using our software. So what does our software calculate in addition to short circuit calculations? You also have cable sizes, circuit breaker sizing, voltage drop calculations, discrimination or selectivity, backup or coordination. So these are some of the calculations which the software can perform. And finally, once you do all the calculations, you need good reports. So we have a wide variety of reports from single line diagrams, calculation sheets, discrimination curve studies, specifications, and also equipment lists. So you can do a complete study, and at the end of the study, not only will you have the complete calculation, but you will also have the bill of material of all the circuit breakers that you require in your project. So this is also a very good feature and benefit that we have of the software. So let me show you the layout that we have on the software. So Elcomnet's user interface, it looks like other Windows operating softwares. So you have the menu command on top. We have 9 different menus, the file, edit, the different menus which are available. On the side, you will see a tree diagram for your project. This tree diagram basically shows all the panels which you will create in your project. So you normally start from your main distribution board, then you have multiple sub-main distribution boards, and then of course the several final distribution boards. So at any point, you can click at any distribution board and you can check what are the calculations on each board. So at board level, you can check the reports. Then we have the calculation report on the bottom. So it shows you what are the calculations that you have been conducting and if it's good or bad. It will show you also the values. We have also the network single line diagram. So basically we need to create your single line diagram, which I will show you in my demonstration how it's done. And then at the rightmost, we have the results window, which basically gives you all the results which you have calculated. So different kinds of results, from the cable sizes to the short circuit calculations to the voltage drop, everything is at a click of a button. You will immediately view it in your user interface. So let me explain to you the steps. So what are the steps that we have to create a study? So in Elcomnet, a project is done from upstream to downstream. So what does that mean? So when I say upstream to downstream, basically we need to start at the source. So we need to identify your supply. So creation of supply is the very first step. So we need to input what is your transformer data. Your choice of power. Maybe it could not be a transformer. It could also be a feeder pillar. It could also be a board. It could be any source of power. But we need to start at the supply. So we input the supply details. We specify the network characteristics. What is the operating voltage? What is the frequency? What is the earthing system? All this comes as part of the network characteristics. Indicate information for the downstream board and choice of protection. Once the supply is done, we start going downstream. So we start creating distribution circuits. So when we do distribution circuits, we start creating outgoing circuits. So we have the supply, we then start creating distribution circuits. We do different outgoing circuits depending upon the type of load. We can have different type of loads. We can have a motor load, lighting load, socket load. Depends upon the type of load which you have. You start creating all these different circuits, and detailed circuit information is necessary here. So you need to enter the consumption, the choice of protection, and also the cable lengths. So this is where the detailed information goes into the software. Once you create all the distribution circuits, you start calculating. Complete network calculation is carried out using a single function. So we just have one single button which can calculate your entire study. And analysis from the results. So I showed you the results window, so we can get a complete analysis of the results, and then also we can get the results from the calculation sheets. Once we do all the calculation, we start preparing the reports. So we have a wide choice of reports. Single line diagrams, calculation sheets, board specifications, discrimination study. These are just some of the reports that you can create from the software. So this is the first window which you will see. This is the creation of supply. So this is where you enter the transformer power, or whatever it is. If you have a feeder pillar, you enter the feeder pillar power, you enter the feeder pillar breaking capacity. So this is, you need a starting point. So this is where you put your supply information. You put all the network information, you put all the link information, and then once this is done, you come to the downstream board. Downstream board is where this the supply is feeding the downstream board. So it could be your main distribution board. For example, you put what is the incoming of your main distribution board. Is it a air circuit breaker, a molded case circuit breaker, MCB, isolator, switch disconnector? You can choose from the drop down menu that is available in this particular window. Once we do this, we start creating the distribution circuits. So here we have the different kinds of loads: motor loads, socket loads, lighting loads, heating loads, capacitor banks. If you have a bus riser, you can choose anything depending upon your project. Once you start entering this, the next step is important. This is where you start entering the consumptions. So what is the loads? You start entering the loads, you start entering the consumptions, you start entering the cables. If you don't know the cable information, you can leave it blank. The software will calculate it for you. And then once all that is done, we start calculating. So you can see that we have different types of calculations and different kinds of information in the results analysis. The cross section of the cable. The calculation criteria also can be chosen by the software. So either you can choose it by the smallest cable that you require, or you can by also by the voltage drop, or by the cross section, by the over voltage. So we have different criteria based on which you can make the selection for the cables. Then we also have the information about the maximum length that is protected by the circuit breaker. We have also the design current, the IB, the current carrying capacity, and also the cross section of the cables. We have voltage drop information, which is shown. Short circuit calculations. So this is the important one. So in the software, we have something called as IK3, IK2, and IK1. So IK3 is basically your three-phase short circuit. IK2 is your two-phase short circuit, and IK1 is your single-phase short circuit. So you have all the three short circuit calculations shown. Then we also have the maximum magnetic setting, and finally you also have the information regarding the discrimination or coordination that is possible in the network. So these are the different kinds of calculations. So you will also see this when I will show the demonstration for the software. Finally, we have the reports. So in the software, you have a wide choice of reports from single line diagrams. So this can be either prepared in A4 or also in A3. So you can do the complete single line diagram and you can print it in an A3 sheet. We have calculation sheet circuits for distribution or for circuit level, or you can also have a conformity sheet, single line diagram, specifications, circuit specifications, curve discrimination. So, and in the curve discrimination, it's very interesting. You get the curves of your upstream breaker and your downstream breaker, and then you can compare the curves and you can see if they are cutting each other, or if they are okay. And then in this case, you can see the discrimination which you can achieve, either total discrimination or partial discrimination. And also the equipment list, as I mentioned earlier, you can get a complete list of the circuit breakers which are required in your project. So what is the air circuit breaker rating, what are your outgoing MCCB ratings. So all at each level you get a full list of equipments that is required for your project. Okay, so this ends my presentation. I will then be showing you a live demonstration of the software. So this gives you a better understanding of the software, and of course you will see that it's okay. So when you open the software, it's blank like this. We do a new study, so you see it's we do new empty document. We do okay. So manufacturer files. So inside the software, we have different kinds of databases. So databases for circuit breakers, databases for fuses, databases for cables, databases for bus bars, for transformers, for generators. different kinds of databases are available inside the software. Of course, as Hager, we manufacture circuit breakers, so we continuously update these databases for the circuit breakers. But for products such as transformers, generators, bus risers, we follow the IEC standards and we follow the standard specifications for these kind of products. So you can see, for example, for the general purpose circuit breakers, we have several databases which we regularly updated, and you can see the number of elements. We have database with going up to 4,000 elements. So you can see these are the different kind of circuit breakers that are available. So air circuit breakers, the different ratings, molded case circuit breakers, breaking capacities, MCBs, isolators, the complete gambit. So once we choose the manufacturer files, we do OK. One thing I forgot to mention is that, for example, if you don't want to use the Hager database, you can also create your own database. So this is also a benefit that we have in the software. You can create your own database and you can input it inside the software. So once we do this, we do OK, and we have the supply window. So we choose the power, so we can choose the power from 30 kVA. We can go up to 2500 power rating. So either we have also the type of supply, whether it's a transformer, a generator, board with IK. So you can determine a board with the breaking capacity, or you can determine a board with the resistance and in X levels impedance. So for example, I will take a transformer here and I will choose, say for example, 1600 as my power rating. We also have the option of number of supplies. So you can choose how many transformers you have in parallel, and characteristics. Either you can set the impedance for the transformer or you can choose the file, and you can see it automatically comes from the database and the manufacturer files which are inputted inside the software. So we also have the option of dry type or oil type transformers, which is inbuilt inside the software. So for this example, I will take a 1600 kVA transformer. The impedance is as from the database, which is 6%. Once we do this, we choose the electrical network characteristics. So you can see the IEC standard is here, the IEC 364. The frequency can be selected, 50 hertz, 60 hertz. Harmonics is something which the calculate does not, which the software will not calculate. So you need to input what is the harmonics you have in your project. So whether it is less than 15%, whether it's between 15 to 33, or if it's more than 33%. So it depends upon the kind of project you have. You need to make the assumption for the harmonics. So a small house, a residential, could be less than 15. A big commercial building could be more than 33%. So it depends. Depends upon the type of project. So we choose the harmonics level. We choose the earthing system. So what type of an earthing system you have in your network, and also of course the type of conductors, whether you start from single phase, three phase with connected earth, or a separated isolated earth. The voltages. So we have different options for voltages. I will choose 400 for this example, and then we put a link. So link is basically the length from your transformer to your distribution board. So in this example, I will take from transformer to main distribution board. So I will put say 10 meters. Okay. We choose the type of cable. So we have either single core, multi core, or option of bus bar trunking. We can also have the option of bus bar trunking, and now you can see, so all the cable information is coming from the IEC international standards. We also have the option of installation. So on what, where is the cable installed? Is it underground? Is it in conduits? Is it in trays, cable ladders? Is it overhead, behind the walls? We have different options which can be selected from this drop down list. And then the core of the cable, whether it's copper or aluminum. And also we have the cables family, so XLPE, PVCE, or EPR. So all these options are available here. We have some temperature factors which can also be incorporated into the software. And then this is where the conductors information can be input. If you don't know this information, you can leave it blank and the software will make the calculation for you. Okay, so once you put this basic supply information, the next step is go to the downstream board. So the downstream board is where you put information for your distribution board. So for example, let me call this main DB1. Okay, so this is my main distribution board. And Okay, so there's 3P plus PEN, which I leave it as it is. Earthing system, I chose PN. And my breaking device is important. So the main incomer for this main distribution board, so I can either choose air circuit breaker, or I could choose a molded case circuit breaker, or an MCB type C and MCB type B, a fuse, a switch, or maybe I can also choose none. So here I will choose air circuit breaker. All right, and I do OK. So once I do OK, it says supply has been modified. Do you want to calculate it? I say yes. It gives me automatically an option for the cross sections. So either I can have two of 800 square mm, three of 500 square mm, depending upon the number of runs of cables. Okay, let me just make this big. Okay, so you see, this is the single line diagram. So this is how it basically comes. So we have your transformer and a length of 10 meters feeding to a air circuit breaker. Now the air circuit breaker selection comes automatically, or you can also make the choice. Yeah, so this is the choice of the air circuit breaker. So depending on your transformer power, the software will automatically choose what is the optimum circuit breaker rating that you require. So for a 1600 kVA transformer, the software chose for us a 2500 ampere air circuit breaker. But of course, sometimes you might need to oversize it considering some derating factors. You can also choose a higher rating. So either you can go for 3200, 4000. In Hager, we have 5000 amps air circuit breakers. So this basically is the complete database for the Hager range of air circuit breakers, which starts from 800 amperes and we go all the way up to 6300 amperes. So we have the complete database inside the software. Uh, this model names are basically just references, part numbers of the uh, air circuit breakers. But what's important is the nominal rating and also the braking capacities, which we have here. So for this example, I will choose the 2500 ampere, which is the minimum that you require for a 1600 amps air circuit breaker. Okay. So once we do this, you see on the right, we have the results window. We have the voltage drop. So it shows a voltage drop of 0.36%. This is the voltage drop from beginning of the installation until the main distribution board. And then we have the short circuit values. So we have IK3, IK2, and IK1. So the three-phase short circuit, two-phase short circuit, and the single-phase short circuit. So the three-phase short circuit, you see maximum it is 34 kilo ampere. So 1600 kVA transformer with a 10-meter distance, normally you should have a short circuit values of 34 kilo ampere with this cross section of 800 square mm cables. Now, the next step is to add distribution circuits. So once we've done this, how do we add new circuits? So we have this tab over here which says new circuit. So you can just click on that and then you will see different types of circuits that you can choose, whether it can be a motor, a socket, lighting, heating. But normally I will choose a board here, basically to just show that a main distribution board feeding a sub-main distribution board. So when it is green, it means it's calculated. When it is blue, it means it's not calculated. So we need to double click on this icon here. And this is where we enter the circuit sheet information. So we need to enter the consumption of this sub-main distribution board. So we basically have the circuit information, we have the protection information, the cable information, and you see on the bottom we have the consumption. So here, for example, I type 100 kilowatt. This is my sub-main distribution board. Okay, a distance of say 20 meters from my main distribution board to my sub-main distribution board. I have 20 meters. I don't make any changes in the cables. I leave the cables blank. I can choose the power factor. As standard is 0.8. I can make it 0.9. I can change it. Harmonics level is also here, which I can adjust. So once I make this settings over here, I come to the downstream board. It's again the same principle. This becomes my S SMDB, submain distribution board 1, control A, control okay, submain distribution board, and here I will choose my incomer as a molded case circuit breaker. I do okay. I did not press calculate button. I pressed OK just to show you, because what we have is that we have an option on top over here, which is a calculate button, a complete calculation button. So either you can uh, enter all your circuits, enter all your loads, all your boards, and then do a complete calculation at the end, or you can do board by board. So for example, here I click and I click on the calculate button. So again, it shows me. So for the 100 kilowatt consumption I put, it gives me an option of the circuit breaker. So what circuit breaker do I need? So again, minimum of 200 ampere. Possibly I will go for a higher one. So I choose 250 ampere, or you can go for the lower one, depending upon your choice. We have the choice of the breaking capacity. So we see the minimum is 40 kiloampere. So we don't have anything less than 40 kiloampere. So we choose a 40 kiloampere breaker. Take care, this is at the main distribution level. It's not a sub main distribution, this is at the main distribution board. This is the outgoing breaker for your MDB. We have the option of poles, whether you can choose a 3 pole or 4 pole, and we just do OK here. And then this is your selection for the submain distribution board incomer. So here also I make a choice of say 200 ampere, 3 pole. I do OK, and this is how it looks. So let me just zoom out a little bit so we see everything. So we have the transformer feeding your main distribution board here. This is the incomer breaker, this is the outgoing breaker. This outgoing breaker is feeding in submain distribution board. And so at the submain distribution board level, again, if you click over here on the right hand side, you will see the voltage drop. So what is the complete voltage drop? So 0.68% now. And again, we have the three-phase short circuit, which is 25 kiloampere. So at the SMDB level, the short circuit is 25 kiloampere. Now the good thing about the software is that we can do one circuit, and then we also have the choice to copy and paste. So copy and paste. So submain distribution board 1, submain distribution board 2, 3, 4, 5, depending upon your project, you can just keep creating how many ever number of boards that you require. And the process is similar. Again, you can go again new circuit if you want to do your final distribution board. So I can just create this very quickly. It doesn't take time. So I choose again, say a length of say 15 meter over here. Say consumption of I put 10 kilowatt. I choose the downstream. So this is my becomes my final distribution board 1, and I will choose my incomer breaker as an MCB. Okay, and I do OK, calculate. So what is the circuit breaker I need for the outgoing of the SMDB? So it's a 20 amps MCCB. I choose OK, and then I have the circuit breaker at the final dB level. So what is the breaking capacity that is required? So 6K, 10K, 25, 50. So we have the full range in Hager. The minimum that is required is 6 kiloampere. So you see, this is the final distribution board level. So at the final dB level, we have a voltage drop of 1%, three-phase short circuit of 4.8 kiloampere. And this is the same thing. You can again copy paste. You can do different distribution boards, and very quickly you can see that we can go from your transformer all the way up to your final distribution board. And here you can do a new circuit. You can go directly to your lighting, for example. So if you want to know at the point of your load what is the short circuit, you can choose a consumption. So we have different kinds of loads which you have. So for example, I choose one, and I choose a length also, say 10 meter. I do OK, calculate. So a 10 ampere MCB and outgoing single pole. So my final distribution board incoming, my final distribution board outgoing, feeding the load directly. So you can see the single phase short circuit in this particular level is 731 ampere. So very quickly, we can go from your transformer all the way up to your final distribution board level. And then with the option of copy and paste, you can copy paste multiple different kinds of boards, and then you can create your complete network. So once we do the calculation, what's next? Next, I would like to show you the reports. So here we have different kinds of reports which you can print for your projects. So we have single line diagrams. We have a very nice report called as the board single line maintenance. Let me show you this particular report. Let me zoom in. Okay, so basically this gives you information about your network, about your distribution, which board are we looking at. So we're looking at main DB. So this is your main distribution board. What is your current? What is your short circuit values? And basically it shows you here what is the consumption of your main incomer, your transformer, and then what are your outgoing circuits. So we have one board of 100 kilowatt, another board of another 100 kilowatt. You see this one is blue in color because I did not calculate it. So we have one board which is green, which is calculated, and then in the bottom you will also see the information regarding the cables and also the circuit breaker. So we have information about the circuit for about the cables. So I put a distance of 20 meters. What is the maximum protection? What is the voltage drop? What is the cross section? And what is the three-phase maximum short circuit that is available, that is in the network. And at the bottom, we have the circuit breaker information. So HWBN325 is the Hager product reference for the air circuit breaker. It's for the 2500 amps air circuit breaker. The X250 is our range of molded case circuit breakers. So we need a 250 amps MCCB here. And this is the circuit breaker selection for the outgoings. So this particular report is a 4-page report. So it shows you each and every board that you have. So the next one will be your submain distribution board. The next will be your final distribution board. So at the final distribution board, what is your 3-phase short circuit? What is a single phase short circuit? You have all this information. So here we have the reports, which is interesting. Last, I want to show you the report for the discrimination. So here we have the discrimination. Maybe I will again make it a bit bigger for you to see it. Okay. So we have the curves for the air circuit breaker, and then we have the curve for the molded case circuit breaker. So between your upstream breaker and downstream breaker, it shows what is the discrimination. And here you can see that we have, in this particular case, total discrimination. So it says we have total discrimination between your upstream and downstream. So the breaker closest to the fault will trip first. So if there is a fault which is close to the molded case circuit breaker, the MCCB will trip and the ACB will not trip, because the ACB is your main breaker. It should not generally not trip. So it's important to have good discrimination in your project. So we have this reports as well. Okay, so I guess this brings the end to my demonstration. I will be going back to my presentation, and if you have any questions and answers, I will be answering them now. But before that, I believe we have the poll, which I think should be on your screens now. So please answer the poll, and the person who wins this particular poll gets a prize. We have a giveaway which is selected and random. So please do answer this poll, and then I will answer your questions which you have entered in the chats. So the question is, a short circuit is an electrical circuit that allows a current to travel along an unintended path with low electrical resistance, medium electrical resistance, or high electrical resistance. So please answer this. We have a minute for you to answer this, and then I will go back to the question and answers from the chats. Okay, so I think that brings the end of the 1 minute. So let's go back to the questions that were asked during the webinar. So let me try and answer them. So do we have any questions? So let me go right at the beginning to see what questions we have. Okay,
You
so
have to stop sharing and then check.
okay, so I need to stop sharing my screen. Okay, I come back to the chat. I need to answer the questions.
The 20.
Okay, so so one question we had was, is it available in your website? Currently, the software is not on our website. We generally share this with the customer when he's requesting us, because we like to do a small demonstration, a small training, and there is also a license that is included along with the software. So normally the software runs for 30 days without any license. After that, you need a license. So this is one of the reasons why it's not just available for anybody to download on our website. If you are very much interested in the software, please contact us. Please contact your sales representative, and we will definitely share a copy of this software with you. It's for all our customers. It's there. It's here to make your life easier. So we will definitely share the software with you. Okay, let's try answering the next question that we have. Uh, Okay, so which one, ICC 3, ICC 2, ICC 1 is the maximum? So ICC 3 is the three-phase short circuit. So it's the maximum short circuit which you can have in a network. So it's basically between all your three phases. ICC 3, it's called between three phases. ICC 2 is between two phases, and ICC 1 is between a phase and a neutral. So ICC 3 is the maximum. Okay, I hope that answers your question. Let's try the next question that we have. Uh, what is the maximum current allowed for in the design software? Does it match the actual circuit breakers from Hegel? So the maximum current today, we have transformers up to 2500 kVA. So this is the maximum current which is possible in the software. It's 2500 kVA. Does it match the actual circuit breakers? Yes, in Hegel we have circuit breakers from 0 0.5 amperes up to 6300 amperes. So I think we cover we cover the full range. Okay, so let me go to the next one. So what is the major difference to what is the major difference from ICM to ICS breakers? I believe you're asking about the different kinds of braking capacities. So we have ultimate braking capacity and we have service braking capacity. ICS is the service braking capacity. So generally, the service braking capacity is a percentage of your ICU values, and in Hager we have a full range from 50% to 100% depending upon the type of a breaker. But basically, the main difference is that an ICS breaker, if it is rated 100% of the ultimate brake capacity, it basically means that it can break the short circuit three times, whereas an ICU is tested for two times the maximum short circuit, and ICS breaker is tested at three times the short circuit values. So it's the difference in the testing of the circuit breaker as per the IEC standards, which is the IEC 60947. So that's the difference in the braking capacities as how it is tested. Okay, so let me go on to the next one. How can I get the Elcomnet software? Basically, again, it's same. Please contact your Hager sales representative, your Hager contact, and we will get you a copy. Uh, Let me answer the next one. Again, it's regarding how can we get it. Please contact your sales representative. How much will it cost? It again depends. Normally, depends upon the relationship which we have with you. So please contact your representative and they will give you more detailed information regarding that. It's again regarding how I can get the software. So please contact your Hager representative. And can Elcomnet schematic be exported to AutoCAD and vice versa? Today, no, we cannot export it to AutoCAD. So we don't have that facility today. So once you do the single line diagram, you can only take printouts or you can all possibly make it in PDFs, but you cannot send it to an AutoCAD version. So today, unfortunately, that is not possible. How do we get the software? Again, please contact your sales representative, your Hager contact. They will give you more information regarding this. From Malta, can this be downloaded from Hager Africa? Again, to get the software, please contact your Hager contact. How good it is compared to ETAP? Well, ETAP is a software which is it's a third-party software, and it has databases for all manufacturers, including Hager. Databases available in ETAP. But you saw the software for yourself. It's very easy. It's very fast. ETAP for me is a little bit more complex. It's a good software. But I find Elcomnet to be more user friendly. So this would be my answer for this. And will there be a course for Hager CAD? We had a webinar last year for Hager CAD, I believe. And if you need more information regarding this, you can go to our YouTube page, and you will find the recording of that webinar on our YouTube page. So you can get more information regarding Hager CAD on the Hager YouTube web page. You will find a recording of Hager CAD over there. All right. Next question. Can we connect uh, multiple transformer and number of generators at common bus bars for finding short circuit? So if you want to connect multiple transformers, yes, you can have up to three. Sorry, not three, six transformers in parallel. It's possible. You can connect multiple transformers, and also you can have a standby generator. Yes, it is possible. Okay, let me go to the next one quickly because we are running out of time. Can you also show connected. I'm sorry, I will not be able to do that at this moment because we're running out of time. Is in the software, what is the impact of current limiters and NGR on bus bars? I'm sorry, I don't completely understand your question. Uh, Mr. Habub, if you don't mind, maybe you can contact us, send us an email, and we will try to answer you. We have your contact details because I don't understand what is NGR. So we will try to answer this later. Let's see a next question that we have. I believe, yes, that is the end of the questions, and I think we are just right on time. So, thank you everybody for attending this webinar. At the end of this webinar, we will have a short poll just for your feedback on this webinar. So please feel free to give your comments and feedback. And please do register for our future webinars because we have a couple of more this year. So do register uh, and we look forward to seeing you more in our future webinars. Thank you so much.